So that's the shoreline. And then from the shoreline, you start in a boat. Here you are in your boat, 500 meters offshore. The question is, where should you row? Are you going to row directly to shore and then run that whole way? Are you going to row all the way to the end and run a teeny bit? Where are you going to land? So you're going to row your boat somewhere, okay, not sure where, and then you're going to run the rest of the way to the finish line. We're going to find out what's the best option. We're going to use calculus to do it. All right, so here we go. This is how you should label these. From here to where you're going to land your boat, we're going to call that x. And so this other area, this part right here, do you know what that would be then in terms of x? Let's see. You will cross the finish line on the walkway 1,000 meters from the shore down. So this is going to be 1,000 minus x. 1,000 is the entire thing. You're 500 meters off the shore, and you end at a point 1,000 meters down the shore from the start line. Okay, that's what that is. The whole thing's 1,000. All right. Now, I don't know what this one is right here. I'm going to call it A.
Can't we find that though?
You can call it Y. Yes. All right, so here we go. We're going to set up everything that we know so far. Okay? So we can go ahead and we know that a squared plus x squared equals, no, sorry.
500.
Yeah, my bad. Let's start that over. Don't get mad at me. Don't you sigh at me, Hannah. It's on video. All right. Sorry, Hannah. You're right. I'd sigh at me too. 500 squared plus x squared equals a squared. There you go. And then just leave it like that. Okay? I'm not even going to find a yet. I hate that. All right. So let's talk about this. There's rates involved in this problem. And we know that distance equals rate times time. Do you remember that?
Sure.
Distance equals rate times time. Yes, it does. So if you're in the car and you're going a certain rate, say you're going 60 miles per hour for 3 hours, you go 180 miles. Distance equals rate times time. We're trying to minimize the time that it's going to take, right? We're in a race. So we're going to say that the big T is equal to the entire time of this whole race is equal to. Now, if distance equals rate times time, then time is equal to somebody's distance divided by the rate that they're going. Do you ever do that in the car? You're driving and it says so you're 180 miles to San Diego and you're like, oh, okay, well, you guys have apps and stuff now. You just look on your app and say how long you're going to be there, right?
Yeah.
Okay. Well, it equals distance divided by rate. So let's do this. Here's your boat. You're going to go this and you're going to go that, right? And that's the distance. You're going to go this distance plus that distance to get there. Well, the distance would be A. So I probably should have taken the square root. So the time that it's going to take is going to be the square root of x squared plus 500 squared divided by the rate. And what was the rate given to us? 270 meters per minute.
But there's 2 of them.
Plus total time, right? That's just the time it's going to take in your boat.
Yeah.
Plus the time on the shore. And on the shore would be your distance over your rate there. And your rate there was what? 320. And now we have to minimize the time that's being spent running this race, right? You don't want more time, the worse you're going to do in the race. So we have to take the derivative of that equation right there. Yeah. Do this. Watch. This is not going to be quotient rule. People look at this. This is what you want to rewrite this like this. Time equals, this is a constant, 1 over 270 times x squared plus 500 squared. We can rewrite that as 250,000 to the 1/2. Okay? Plus, over here, this is going to be 1,000 over 320 minus 1 over 320 times x. Okay? I did that so that I can take the derivative. It's going to be a lot easier to take the derivative of all this when it's written like this. So here we go. Let's take the derivative now. You take the derivative of the first one. You're going to bring the 1/2 down to the front. You get 1/2 times 1 over 270. Leaving the inside alone, subtract 1 from 1/2. So x squared plus 250,000 to the negative 1/2 times what? Does anyone know? 2x. Chain rule. Good job. Okay? So the derivative of this is just a constant out front. Take the derivative, subtract 1 off, then take the derivative of the inside. Okay? And then take the derivative of this. What's the derivative of 1,000 over 320? 0. And the derivative of negative 1 over 320 times x? Negative 1 over 320. Good. It's just a constant in front, right? Okay. So now we have a 1/2 and a 2x. Those 2's can cancel out. The 1/2 times 2. And I'm going to set everything equal to 0 and solve. So 0 equals. This is to the negative 1/2. It's going to move to the bottom. So what do I have up top? I have an x still. That's this x right here. And on the bottom I have 270 times the square root of x squared plus 250,000 minus 1 over 320. We see that a lot whenever we're minimizing. We have that over square root thing. Okay, let's add the 1 over 320 to the other side. So you get 1 over 320 equals all this stuff. I'm going to write it again. Ooh. Square root x squared plus 250. Okay? And now let's go ahead and cross multiply to solve. So we get 320x equals 270, bless you, times the square root of x squared plus 250,000. Okay. Let's divide both sides by 270 to get rid of that. 270, oops. Okay. And so we get 32x over 27 equals the square root of x squared plus 250,000. All right, this gets pretty gross. Now we need to do what to both sides? Square both sides. We're going to square that, and we're going to square that. All right, let's do this part. 32 divided by 27 squared. We'll just get a decimal. It's 1.405 x squared equals x squared plus 250,000. This isn't so bad. It's a quadratic, but it only has an x squared term. It doesn't have an x. You're not going to have to do quadratic formula. So subtract 1x squared over, and you get 0.405 x squared equals 250,000. Okay, so take 250,000 and divide it by 0.405. Whoa. And then you get x squared equals, I got like 617,796.6102. You didn't get that?
You have a bunch of commas in there.
Sorry, let me erase one.
How did I just didn't use my count. I didn't get my calculator.
There we go. Good?
Yeah.
Okay? And then take the square root of that.
What happened to the x squared that you subtracted?
This is 1.405 minus 1 gives me 0.405 x squared. I subtracted it to the other side. All right, and I get that x is about 786 meters.
Do you want us just to know? We just need to
Sure.
positive? We don't need
About.
plus or minus?
We don't need plus or minus. Nope. So let's go back and see what the question's asking. It's saying, how far from the finish line should you aim your boat? So you should aim your boat about 786 meters down. So my drawing's a little off. This looks like about 500 because it looks like halfway. But it looks like you should row your boat a pretty good distance to here and then run the rest of the way. What?
1,000 minus what we found?
It depends on what they ask. All they asked was how far from the finish line should you aim your boat. They just ask for X. But if they asked you that, or they asked you how far are you going to row your boat, you'd have to find out what A was.
You plug it back in.
You plug it back in, or how far is that? So X is 786, about 786 meters. And then it could ask, yeah, how far are you going to run? So you're going to run about 214 meters. There you go. See? Calculus just helped you win that race. The row-run race. Pretty good? That's a hard one, huh? Anytime a triangle's involved, things get real scary. All right, let's go to the next one. And this is it. If you hate these, you know, and some of you do, that's okay. Then we're almost done with them. All right, maximum profit. We're just going to review on Thursday if you're here. All right, so it says here that you need to know some things about profit. P of X, the profit, is equal to the revenue function minus the cost. Okay? You learned that in ham probably. And you're going to take P prime of X and set it equal to 0 to find the maximum profit.
You don't have that, so just write it on the...
Oh, you don't? Oh, I'm sorry. This is an older version, and I changed it. Sorry about that. Just write that like in the problem. You can write it there. I have the same one you guys do. It doesn't have it that way either. Okay, so the maximum profit is when P prime of X, the profit function of your variable, is equal to 0. So it's also equal to when the revenue derivative equals the cost derivative. When you set them equal to each other. Think about it. If you're going to sell cookies, okay, and then people give you money, you make $100. Well, you have to subtract out what it cost you to make those cookies. My kids are always like, oh, let's sell lemonade. I'm like, okay, how are you going to buy the lemonade? You know, like.
Get along.
Jerky mom, huh? Okay, so here we go. It says here that suppose that R of X equals 9X and C of X equals X cubed minus whatever. Okay. X represents thousands of units. Is there a production level that maximizes profit? All right, so you can do this a couple different ways. You can actually find the profit by taking R of X minus your cost and then do that. Or you can just take the derivatives of them separately and then set them equal to each other. I like to do it that way. I like to find when R of prime of X is equal to C prime of X. So what is R prime of X? 9. And what's C prime of X? It's 3X squared minus 12X plus 15. All right, so subtract 9 to the other side, and you get to use your program. Yay! So you go to your quadratic formula program in your calculator that Mr. Shredlin gave you, and you figure it out. Beep, boop, beep, boop. You get 2 answers. The answers are about 0.586 and 3.414. Okay, what happens is this first one, this 0.586 is actually a minimum, and this will give you a maximum.
How do we know that?
If you plug it back in, to revenue or into your profit equation if you want to, which is revenue minus cost, you're not going to make anything. It's like, it's bad. You have to check it. So if you plug this back in to here, you'll see that that's going to be a maximum.
Will it always be the bigger number?
Yeah. Yep. And so is there a production level in thousands of units? Yeah, so you would want to do 3,414 units is what you want to make to maximize your profit. If you make more, you're going to lose money. If you make less, you're not going to sell as much. That's like the... It is, yeah.
To break even?
Okay, minimizing cost. Oh, because X was in thousands of units. Okay, you probably don't have that either, huh? Minimizing the average cost. This is what you want to write down. C prime of X. They call this the marginal cost. Marginal cost. And what it's equal to is it's equal to C of X divided by X. Average cost. And you want to find out when the marginal cost and the average cost are equal to each other. Okay? So here we go.
So you want C prime of X equals
C of X over X. So the marginal cost is going to be the derivative of the cost function. So let's first take the derivative of C of X. So the derivative of C of X is 3x squared minus 12x plus 15.
It's the same, right?
It's the same what?
As the top.
Yeah. And then C of X over X is going to be the average cost. This is the cost per each thing that you're making. It's the average cost. So then you take x cubed minus 6x squared plus 15x, and you divide everything by x. When you do that, you get x squared minus 6x plus 15. And then what you want to do is you want to set those equal to each other and solve. So you want to set the marginal cost equal to the average cost. So let's do that. So 3x squared minus 12x plus 15 equals x squared minus 6x plus 15. I know this feels weird having economics at the end of this chapter or this lesson that we've done, but it's all about maximizing and minimizing. We've done area and volume, and then all of a sudden they want to maximize or minimize cost and production and profit and stuff like that. Okay, so let's solve this. Do you know how to solve this? Yeah, subtract x squared over. You get 2x squared. Let's add 6x over to get negative 6x, and then subtract 15 equals 0. Go ahead and take 2x out. And so our answers are 0 and 3. Yeah, and these are in thousands of units. We don't want 0. 0 is going to minimize your cost or your production. That means you don't make anything. I mean, yeah, you could do that. That would minimize your cost if you don't make anything. Yeah, minimize your profit too. So you would want to make 3,000 units because this is in thousands again.